Okay, good morning everyone. Our lesson today is lesson 10.1, solving system of linear equations using matrices. What are matrices? We can simply say matrices are the plural of a matrix, and a matrix is a table of numbers of a rectangular array of elements. For example, this is a matrix 5, 1, 2, 3, 0, negative 5, and we denote it by the letter A. This matrix is called a 2 by 3 matrix. Why is 2 by 3 matrix? The 2 represent the number of rows, and the 3 represent the number of columns. 3 represent the number of columns. So 3 the number of columns. So it's a 2 by 3 matrix. So and we are going to use matrix to represent a system of linear equations written in standard form. To do so, we extract the equations of each term in the equation to form an augmented matrix. So let's take this system of equation. Let's take this system of equation: 3x plus 2y equals to 5, x minus 2y plus 3z equals to 1, and 2x plus y plus 4z equals to 8. Now, first question, we need to look at this system of equation and we need to check, is this equation written in standard form? What do I mean by standard form? The variable should be on the left side and the constant term should be on the right side. So we have 3x plus 2y equals to 5, x minus 2y plus 3z equals to 1, 2x plus y plus 4z equals to 8, and this system of equation is written in standard form. Actually, it is written in standard form. We need to change it to a matrix or an augmented matrix. We start by taking the coefficient of x, which is 3, coefficient of y, it's 2, and coefficient of z is 0. So we consider taking it in alphabetical order, 3 to 0, and we put a vertical bar. This vertical bar separates the coefficient of the variables with the constant term. Here we put 5, and here we put 1, negative 2, 3, the constant term is 1, 2, 1, 4, and 8. 2 is the coefficient of x, 1 is the coefficient of y, and 4 is the coefficient of z, 8 is the constant term. This matrix is called an augmented matrix, and we are going to use augmented matrix throughout the lesson in solving the system of linear equations. So now, our first goal in this lesson, our first objective is to learn how to convert a system of equation into an augmented matrix, and this goal is fulfilled here. So simply, if we have a system of equation, we can simply convert it to an augmented matrix, and this is how. Let's take an example. Let us take an example. Let's consider this system of equation. Example 1. Let's take 2x equals to 5y plus 5, and let's take 3 into 2x plus y equals to 17 plus y. So we have this system of equation. Now, first question, is it written in standard form? Apparently it's not. So what do? I need to convert it to, or I need to change it to standard form. I need to solve and change it to standard form. So simply we can say 2x equals to 5y plus 5. I can subtract 5y from both sides, and here let's use the distributive property. We have 3x plus 3y equals to 17 plus 5, and then finally we can write it in standard form. the first equation, 2x plus minus 5y equals to 5, 3x 3x, subtract y from both sides, 3x plus 2y equals to 17, and this equation is written finally in standard form. Now we can write its augmented matrix. Don't forget the vertical bar here that separates the coefficients with the coefficient of the variables with the constant term. So we have our augmented matrix. This is our augmented matrix. Okay, so our goal, our first objective in this lesson is to convert the equation from convert the system of equation to augmented matrix. Okay, let's continue. Let me give another example. Example 2. In this example, I will give you the augmented matrix, and we will change it to a system of equation. So let's take this augmented matrix: 1 0 0 0 1 0 0 0 1 6 negative 10 and 4. Okay, I need to convert it to system of equation. It will become x equals to 6, because here 1x plus 0y plus 0 that equals to 6. And the second one, 0x plus 1y equals to negative 10, and the last one, z equals to 4. This matrix here is written, this augmented matrix is written in reduced echelon form. What is the reduced echelon form? The leading coefficient is 1 for the first row, the second row also is 1, and the third row is 1, the leading coefficient. And look at the leading coefficient here. The first leading coefficient 1, look under it, all of the numbers are zeros. And now look at the second one, the leading coefficient 1 here, the numbers above it and below it is zeros. And so for the third row, the leading coefficient here is 1, the numbers above it are zeros. So this one is written, this augmented matrix is written in reduced row echelon form. Okay, we will talk about row echelon form and reduced echelon form throughout the lesson. Okay, throughout the lesson we will use the following elementary row operations to solve any system of linear equations using augmented matrix. So what are the elementary row operations? First operation, interchange rows. What do I mean by interchange rows? I can flip row 1 with row 2. So I can take row 1 and put it instead of row 2, and same thing for row 2 I will put it instead of row 1. Example, negative 3, negative 5, 1, 2, negative 13 and 5. Okay, I will interchange row 1 with row 2. So this will what will happen: 1, 2, 5, negative 3, negative 5 and negative 13. These two augmented matrices are equivalent. Okay, the second row operation. Second row operation, we can multiply a row by a non-zero constant. Example, let's take this augmented matrix: 3, 6, 5, 8, 9, 10, -1, -2, -3. I can simply, let's multiply R2 by 4. Let's multiply R2 by 4. Let's multiply R2 by 4. 3, 6, 5. R2 by 4. 4 times 8, 32. 4 times 9, 36. 40, -1, -2, -3. Also, these two matrices, or these two matrices, the first one and the second one, are equivalent. Now the third row operation, we can add or subtract. We can add or subtract a non-zero multiple of one row to another row. Example: 1, 2, -3, -5, 5, -13. I'm going to multiply R1 by 3 and add it to R2. I'm going to multiply R1 by 3 and add it to R2. So again, multiply R1 by 3 and add it to R2. So which row will change? R2 will change. So R1 will remain as it is. And let's multiply R1 by 3. It will become 3, 6, and 5. And I'm going to add it to R2, -3, -5, and -13. 3 plus -3, 0. 6 plus -5 is 1. And 5 plus -3, 13 is going to be -8. So also these two matrices are equivalent. Okay, we are going to use this operation throughout the lesson to solve system of linear equations. Okay, our second objective in this lesson is to solve a system of linear equations using Gaussian elimination. Okay, so let's consider this system of equations. Okay, so we have this system of equation. Three equations, three unknowns, and we are going to solve it using Gaussian elimination. Okay, first step is to convert it to an augmented matrix. And it's very easy. We can convert it to an augmented matrix. It will become 1, 1, -1, -2, 2, -1, 1, and 5, -1, 2, 2, and 1. Okay, My target is to use the elementary row operation and to convert these three numbers to zeros and these three numbers to 1. So I need to convert the 2 and -1 to zeros, and 1 -1, and 2 to ones, using the elementary row operations. So what should we do? So what I'm going to do is to add R1 to R3. Since I'm adding R1 to R3, R1 will remain as it is, 1, 1, -1, -2. Also, R2 will remain as it is. What about R3? If we add R1 to R3, 1 plus -1 is 0, 1 plus 2 is 3, and -1 plus -1 plus 2 is 1, and -2 plus 1 is -1. Okay, second step. I'm going to multiply R1 by a -2 and add it to R2. So -2 R1 plus R2. I'm going to multiply R1 by a -2 and add it to R2. R1 will remain as it is, 1, 1, -1 and -2. R3 will remain as it is. Okay, R2 will change. I'm going to write the result of the product of R1 by -2 above the elements of R2. So, and then we'll do the calculations. So here we have 2, -1, 1, and 5. Okay, what I'm going to do, R1 multiplied by -2, 1 times -2 is -2, and 1 times -2 is -2, -2 times -1 times -2 is 2, and -2 times -2 is 4. Now I'm going to add these two together. So, and the result would be as follows. The first row will remain as it is. Second one, -2 plus 2 is 0. -2 plus -1 is -3. Two plus 1 is 3. 4 plus 5 is 9. Now, and the third one will remain as it is. Okay. So if you notice, we are reaching our destination, which is converting these three to zeros. I converted 2 of them. I still have 1 more to go. Second operation. What do you think we should do? What do you think we have to do next? It's simple. Let's add R2 to R3. Add R2 to R3. We will add R2 to R3. we will add R2 to R3. So R1 will not change, R2 will not change, R3 will change. R2 plus R3, 0 plus 0 is 0, negative 3 plus 3 is 0, 3 plus 1 is 4, 9 plus negative 1 is 8. So now we have our new matrix. Okay, let's continue. Remember, I need to convert these three numbers to 0 and these three numbers to 1. So what do? We still have one more step to do, and we are done. What do? I'm going to multiply R2 by negative 1 over 3, multiply using the second row operation, R3 by 4, and we are done. This will be my matrix. 1 1 negative 1 negative 2 0. Okay, 0 times negative 1 over 3 is 0, negative 3 times negative 1 over 3 is 1, 3 times negative 1 over 3, remember I'm multiplying R2 by negative 1 over 3, 3 times negative 1 over 3 is a negative 1, and 9 times negative 1 over 3 is negative 9 over 3, which is negative 3, and here we have multiplying by 1 over 4, multiplying by 1 over 4, 0 times 1 over 4 is 0, 0 times 1 over 4 is 0, 4 times 1 over 4 is 4 over 4, which is 1, 8 times 1 over 4, 8 over 4, which is 2. Now we are done. How we are done? Because we changed the original matrix into row echelon form. What do I mean by row echelon form? The leading coefficient here is 1, leading coefficient is 1 here, and leading coefficient is 1, and these three numbers are zeros. So row echelon form, by definition, what are the steps to do in order to change a matrix into row echelon form? You can refer to your book to page 1 minute to page 884, row echelon form and reduced row echelon form. A matrix is in row echelon form if it satisfies the following conditions. What are these conditions? Any rows consisting entirely of zeros are at the bottom of the matrix. This is the first condition. Second condition, for all other rows, the first non-zero entry is 1. This is called the leading coefficient. So as we said, the leading coefficient, the first entry should be 1. Okay, leading coefficient should be 1, and the third condition, the leading 1 in each non-zero row is to the right of the leading 1 in the row immediately above it. So this is the row echelon form. Okay, what about reduced row echelon form? A matrix is in reduced row echelon form if it is in row echelon form with the added condition that each row with a leading entry of 1 has zeros above the leading 1. So we'll talk about reduced row echelon form, or let's talk about it now. So look at this leading coefficient. Below it should be all zeros. Now let's look at this leading coefficient. Above it should be zeros, and below the above elements should be zeros, and the below elements should be zeros. Also, this leading coefficient in the third row, above it all the elements should be 0. So apparently this matrix is in row echelon form, not in reduced row echelon form, and I'm going to explain the reduced row echelon form in a bit. So now, since going back to our exercise, since we since we wrote the matrix, the original matrix here, the system, the augmented matrix, we convert it to row echelon form. Now I can do the back substitution. What do I mean by the back substitution? Let's start with the third row, the last row. I can say y equals to 2. Sorry, z equals to 2. Z equals to 2. Now I found z. Now going to the second row, I can say that y minus z equals to negative 3, and I already know that z equals to negative 2. I can solve for y. Y minus 2 equals to negative 3. That means y equals to negative 1. And going back to the first row, I can say that we have x plus y minus z equals to negative 2. X plus y minus z equals to negative 2, and we have y and z from the first two equations, so we can substitute. Let's substitute. X plus negative 1 minus 2 equals to negative 2. That means x minus 3 equals to negative 2, which is equal x equals to 1. So the solution will be x equals to 1, y equals to negative 1, and z equals to 2, and we solve the system of equations. Now, third objective. Okay, let's continue. The last objective in this lesson, the last idea, is the Gauss-Jordan elimination. It's the same as the previous process. It's a process that we're going to use to solve system of linear equations. Okay, but instead of converting the augmented matrix to row echelon form, I'm going to convert it to reduced row echelon form. What do I mean by that? It's simple. We need to convert these three numbers to zeros, these three numbers to zeros, and the numbers that are at the diagonal of the augmented matrix should be, we're going to convert them to 1. So the first process that I'm going to do, the first operation that I'm going to do, is I'm going to interchange row 1 with row 2. I'm going to interchange R1 with R2. So I interchange R1 with R2. Next step, next operation, I'm going to multiply R1 by negative 2, and I'm going to add it to R2. So as you notice, R1 will not change and R3 will not change. One, 3, 2, negative 8. Okay, I'm going to write R2 as it is. I'm going to write the result of multiplying R1 by negative 2 above it, and then we'll add. So it's going to 2 and negative 5 and negative 21 and 39. Okay, let's look at R1. If I multiply R1 by a negative 2, 1 multiplied by negative 2 is negative 2. Negative 3 multiplied by negative 2 is negative 6. Negative 10 multiplied by sorry, positive 6, negative 10 multiplied by negative 2 is 20, and 22 divided by negative 2 is negative 44. Okay, let's add them. Negative 2 plus 2 is 0. Positive 6 plus negative 5 is 1. Next 21 plus 20 is negative 1. And 39 plus negative 44 is negative 5. So I can simply write here 0, 1, negative 1, and negative 5. Okay, now next operation is that I'm going to multiply R1 by negative 1 and add it to R3. I'm going to multiply R1 by negative 1 and add it to R3. What will happen? R3 will change. That means R1 will remain as it is, R2 will remain as it is, while R3 will change. I'm gonna write R3 the same procedure. I'm gonna write as it is. I'm going to put the result of multiplying R1 by negative 1 above it with a different color. So multiplying R1 by negative 1, this will become negative 1, this will become 3, this will become 10, and this will become negative 22. If we add them together, negative 1 plus 1 is 0, 3 plus 3 is 6, 10 plus 2 is 12, and negative 22 plus negative 8 is 30. So we can erase them. Zero, 6, 12, and negative 30. Directly, I'm gonna divide R3 by, or multiply R3 by 1 over 6. So R3 will change only 1, negative 3, negative 10, and 22. 0, 1, negative 1, negative 5. 0 times negative 1 over 0 times 1 over 6 is 0. 6 times 1 over 6 is 6 over 6, which is 1. 12 times 1 over 6, which is 12 over 6, 2. Negative 30 times 1 over 6 is negative 5. Okay. Second process. I need to multiply R2 by, I'm going to multiply R2 by negative 1 and then we'll add it to R3. Just look here. If I multiply R2 by negative 1, I will have 0, negative 1, 1, and 5. And if I add it to R3, negative 1 plus 1, 0. And bingo, we got 0, 0. So this is the idea. What will happen? 1, negative 3, negative 10, and 22. 0, 1, negative 1, and negative 5. And as I did before, I'm going to write it exactly as it is, and I'm going to write the result of multiplying R2 by negative 1. This becomes 0. R2 times 1 is negative 1. Here 1, and here 5. Add them together. 0 plus 0 is 0. 0. Negative 1 plus 1 is 0. 1 plus 2 is 3. And negative 5 plus 5 is 0. Okay. Let me write it again here. sorry. Okay. Next, I'm going to multiply R3 by 1 over 3. So 1 over 3 R3. 1, negative 3, negative 10. 22, 0, 1, negative 1, negative 5, 0, 0, 1, and 0. Okay. If you notice here, it's in row echelon form. Why it's in row echelon form? We have these are zeros and these are ones. Now, I said we need to convert it to reduced row echelon form. Not to row echelon form, we need to convert it to reduced row echelon form. That means I need to change these three numbers to zeros. I need to change these three numbers to zeros. So we need to continue using the operations to reach our destination. So what I'm going to do is I'm going to multiply R2 by 3 and add it to R1. I'm going to do it mentally and quickly because you already know the procedure. So what will happen? So I'm going to multiply R2 by 3 and add it to what? Add it to R1. So the second row will not change. The third row will not change. The first row will change. So 3 multiplied by R2, 3 times 0 is 0 plus 1 is 1. 3 times 1 is 3 plus negative 3 is 0. 3 times negative 1 is negative 3. Negative 3 plus negative 10 is negative 13. 3 times negative 5 is negative 15. Negative 15 plus 22 is 7. Now we got a 0. We still have negative 13 and negative 1 to convert them to 0. What I'm going to do, it's also very simple. I'm going to multiply R3 by I'm going to multiply R3 by 13 and add it to R1. Also, I'm going to multiply R3 by R2 and add it to R2. So again, I'm going to multiply R3 by 13 and add it to R1. Also, I'm going to add R3 plus R2. So we have this matrix 1, 0, negative 13, 7, 0, 1, negative 1, 0, 0, 1, negative 5, and 0. So what I'm going to do, I'm going to multiply R3 by 13 and add it to R1. Also, I'm going to add R3 to R2, and R3 will remain as it is 0, 0, 1, 0. So if we add R3 plus R2, if we add R3 to R2, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus negative 1 is 0, 0 plus negative 5 is negative 5, and then let's multiply R3 by 13 and add it to R1. 13 times 0 is 13 plus 1. 13 plus 0 is 0 plus 1 is 1. 13 times 0 is 0 plus 0 0, and 13 times 1 is 13, plus negative 13 is 0, and 13 plus 0, 13 times 0 is 0, plus 7 is 7. Now we got our answer. This is the reduced row echelon form of the augmented matrix, or the first the set of equations, and we can simply say x equals to 7, y equals to negative 5, and z equals to 0. And thank you so much. This is the lesson. Thank you.